Pick up your phone right now. Look at it. It's probably been with you for months. You know every button, you know every app. But here's what most people don't ask. Do you actually know where this came from? Not the Apple Store, not Amazon, I mean, where it actually came from. Because the answer will blow your mind. Welcome to the supply chain behind everything. I am Daksh, and while we usually go behind the scenes to uncover the fascinating journey of how things reach you, today we are also exploring and raising some fundamental and probably ethical questions that supply chain needs to answer right now. Let's follow one phone, just one, from the ground to your pocket. Right now in your hand, there are parts from over 200 different manufacturers. Not 20, not 50, over 200. Some of these companies, you've heard of them: Apple, Samsung, Sony. Most of them, you never will. This one phone connects you to mines in Central Africa, semiconductor foundries in Taiwan, display factories in South Korea, camera sensor labs in Japan, assembly plants in China and Vietnam. And here's the invisible part: millions of tiny components have already traveled across continents, undergone multiple transformations, been refined dozens of times, all before they even arrive at the final factory. This isn't made in China. This is a story of globalization so complex, no single person could document it completely. What we are holding is not just a product, it's a masterpiece of logistical coordination, and it's surprisingly fragile. A phone's journey starts not in a factory, it starts in the earth. Every smartphone begins in mines. Some are huge industrial operations, others are small, informal pits where people dig with shovels. Inside your phone's battery is cobalt. Here's the uncomfortable part: 7 out of every 10 grams of that cobalt came from one country, the Democratic Republic of Congo. The DRC produces roughly 70% of global cobalt. It's essential. Without it, your battery would overheat. It would catch fire. But here's where it gets darker. About 80% of Congo's cobalt comes from large industrial mines, standard operations. And the other 20%, that comes from artisanal mining, informal, unregulated. And in those artisanal mines, digging in hazardous conditions with minimal safety equipment, are approximately 40,000 children, some as young as 7 years old. One fifth of your phone's battery may carry the fingerprints of modern day child labor. Once extracted, about 80% of that cobalt gets shipped to China. A single country handles nearly all the refining. That's concentration number one. Now, let's talk about something most people have never heard of: rare earth minerals. These 17 exotic metals do something critical. They power your vibration motor, they handle your display, they're your magnets, your sensors, your camera. But here's the problem: China controls 97% of the world's refined rare earth supply. Even if rare earth ore is mined in the United States, and it is at a place called Mountain Pass in California, it still gets shipped to China for processing. Why? Because no country or no other country has figured out how to do it at scale. The refining process requires specialized chemical technology that took China decades to perfect. It's capital intensive, it's complex, and it's basically impossible to replicate quickly. This means if China decides to restrict rare earth exports, your phone doesn't get made. Full stop. And that's concentration number two. But we're not done yet. Your battery's solder joints, that requires tin. Your phone's metal components, that requires tungsten. Your capacitors, the tiny components managing electrical current, that's tantalum, derived from something called coltan ore. And your connectors, those need gold. These are called conflict minerals. And here's why. At least 40% of the world's tantalum comes from the Democratic Republic of Congo, specifically Eastern DRC. And that region is controlled by armed groups. Unlike cobalt mining, which is dominated by multinational corporations, tantalum is extracted by thousands of local miners working in open pits, often in perilous conditions. The mineral weighs less than half a garden pea in your phone, but its supply chain is entangled with armed conflict. So at this point, a phone has already connected you to child labor in Congo, military controlled mining regions, highly concentrated processing choke points, environmental devastation, and it's still not even a component yet. Well, let's move to the modern tech facility where these raw materials become black magic. Now, those raw cobalt, rare earths, and conflict minerals get transformed into the actual components that make your phone work. And this is where the story gets really, really concentrated. The chip, the Taiwan's dominance. Inside your phone is a processor. Modern ones contain over 100 billion transistors. Each one is just a few nanometers wide. That's a fraction of the width of a human hair. Creating this requires one of the most technologically demanding manufacturing processes on earth. One company makes nearly everything. TSMC, Taiwan Semiconductor Manufacturing Company. TSMC alone produces 64% of all advanced chips globally. Apple's chips, TSMC. Nvidia, TSMC. Qualcomm, you guessed it right, TSMC. Taiwan, single island, dominates the world. And here's why. Creating a chip requires over 1,000 manufacturing steps. Each one must be executed with absolute precision. A single speck of dust, a microscopic variation in temperature, and the whole batch is ruined. This happens in clean rooms, automated, heavily filtered air, protective suits. And here's the vulnerable part. A single chip's journey from silicon wafer to finished product crosses international borders 70 times over 100 days. Just-in-time manufacturing at its most extreme. And Taiwan is an island near China. The geopolitical risk is also at its highest level. Well, if the processor is the brain, the display is the eyes. Your phone's screen is probably OLED. That means each pixel generates its own light, deeper blacks, better contrast, the thin, flexible screens you expect today. A handful of companies control this. In displays, it's Samsung, LG, and a few others. Samsung Display and LG Display produce over 1 billion OLED panels annually for smartphones worldwide. Samsung supplies displays to both Apple and Samsung Electronics. It's essentially indispensable. But here's the twist. Chinese competitors are catching up. In 2017, South Korean companies controlled 93% of the market. By 2022, that dropped to 71%. Chinese manufacturers, BOE, Visionex, Tianma, are investing heavily. They're targeting mid-range phones, building expertise, and eventually they will dominate too. Your camera takes incredible photos. That's because of CMOS image sensors, devices that convert light into electrical signals with extraordinary precision. Sony dominates this market. They pioneered back illuminated sensors that capture light more efficiently. They have developed 3D stacked sensors using copper to copper bonding. Each pixel must be perfectly aligned. Any manufacturing defect, the sensors are unusable. Well, now, here's where it gets uncomfortable. All those components need to arrive at the same place at the same time, down to the hour. The China Center. This is Foxconn's iPhone City in Zhengzhou, China. 2.2 million square feet. At peak capacity, approximately 300,000 workers. This single facility produces the bulk of Apple's iPhones. At this point, our phone has already crossed 3 continents. China produces 70 to 80% of the world's smartphones, about 1 billion phones annually in one country. But here's the hidden dependency. China doesn't just assemble phones, it also manufactures the highest value components. Apple tries to diversify. They're moving assembly to Vietnam, India, Thailand. But even phones made in India depend on components, 90% of which are sourced from China. You can move the factory. You can't escape the component dependency. The final assembly is a mix of robots and humans. Robots handle repetitive precision tasks, placing components, applying adhesives, inserting screws. Human workers do tasks requiring judgment, inspecting quality, routing cables, final testing, and the entire operation is just in time. Components arrive, they are assembled, the phone ships within hours. This is efficient, it's elegant, but it's also terrifyingly vulnerable. If there's a component shortage, even for one part, the entire line stops globally. A phone now travels by air and sea from factory to your doorstep. This should be the easy part. It's not. The past 5 years exposed something terrifying about these supply chains. In 2021, Taiwan had its worst drought in decades. Semiconductors need massive amounts of water to manufacture. Production halted. That single drought contributed to a global chip shortage that cascaded through every industry: cars, appliances, everything. COVID-19 lockdowns in Shanghai and Zhengzhou shut down component suppliers and factories. Global ripple effect within days. Right now, at this moment in 24-25, shipping reliability has crashed. Pre-COVID, shipment schedules were on time about 70 to 85% of the time. Today, it's around 50-55%, meaning roughly half of scheduled deliveries are late. This isn't friction, this is systemic fragility. And here's the deeper problem: every critical node is concentrated. Taiwan dominates advanced chips. South Korea dominates premium displays. China dominates rare earth processing. DRC dominates cobalt. If any of these goes offline, geopolitical tension, natural disaster, pandemic, phones can't be made. There's no backup plan, no buffer stock. Just in time means zero redundancy. Companies are finally waking up though. Apple is shifting from made in China to China plus one. Manufacturing in India, Vietnam, Thailand, spreading the risk. Samsung has pioneered circular battery supply chains, recovering cobalt from waste devices and reusing it, reducing mining dependence, creating redundancy. Companies are investing in digital supply chain visibility, AI predicting disruptions before they happen. But it's slow, and it might already be too late if tensions escalate. So, anyway, here's what we've learned. This phone in your hand, it connects you to 40,000 children mining cobalt in Congo. Semiconductor fabs in Taiwan operating under geopolitical threat. Water-starved regions where rare earth processing consumes massive amounts of water. Supply chains so just in time they snap under the slightest pressure. A system optimized entirely for efficiency with zero resilience. And here's the environmental part. 85% of this phone's carbon footprint comes from manufacturing. Integrated circuit production alone accounts for 66% of manufacturing emissions. And add mining, refining, shipping. It's a massive carbon burden concentrated in the production phase. Some companies are starting to change. Apple claims carbon neutral operations by 2030. Samsung's circular battery program recovered 90% of cobalt from waste. Fairphone builds modular phones with fair labor practices. But most still chasing pure efficiency, still optimizing for cost, still accepting the human and environmental trade offs. The true miracle isn't that your smartphone works. The true miracle is that despite its impossible complexity, 200 plus suppliers, 1000 plus manufacturing steps, 70 plus border crossings, just in time logistics dependent on Taiwan not going to war, China not restricting rare earths, Congo not destabilizing further, it works at all. But that fragile miracle is under greatest pressure than ever. If you found the supply chain story interesting, there are more like this on the channel. We've covered dark stores, the Suez Canal Ever Given incident, and more. Subscribe if you want deep dives into the systems that power your daily life, the systems that seem simple on the surface but are mind bogglingly complex underneath. Thanks for watching. I'm Daksh, and this has been the supply chain behind everything.